Okay, so let's work here on some questions from the exam to review worksheet, right? The first question here is oxidation number. It's about chapter 4. What is the oxidation number of iodine in potassium iodate here? So the first thing, this is a compound. There is no charge here, right? That means the total will be 0. Okay. And then you have potassium here. Potassium is an element that's in group 1. So the elements group 1 here, they will have oxidation number +1. So the potassium here is +1. Iodine, we don't know yet. Let's call X. And oxygen, right? Oxygen is usually -2. The oxidation number for oxygen is usually -2. Now let's do the math here. 1 times 1 here, plus you just have one I. Let's call X. And then -2 times 3, -6, right? So your X here will be, do the math here, right? Will be +5. So the answer is D here. Okay. Oxidation is the loss of electrons, and reduction is the gain of electrons. So try to remember like this oil oxidation is loss, and reduction is gain. It's just a silly tip for you guys to remember about oxidation and reduction, okay? Here. So the answer is C. Oxidation is loss of electrons and reduction is gain of electrons. So the answer is C. Right? Now, question 3. This question here, a 0.355 molar potassium sulfate solution can be prepared by, so we need to calculate one by one to figure out which one will make this solution here, right? Okay. So let's look at the first one. The first one says dilution of 500 milliliter of 1 molar potassium sulfate to 1 liter. Okay, let's work with this letter A here. This letter A is talking about dilution. So what's the formula for dilution? MC. We see, right? That's molarity of the concentrated solution times the volume of the concentrated solution equal to molarity of the diluted solution times the volume of the dilute solution, right? Now let's figure out which one is which. So a dilution of 500 milliliters, that means this one here will be your volume from the concentrated solution. I'm going to convert to liters, be 0.500 liters here. And the dilution of 500 milliliters of 1 molar potassium sulfate. That means this 1 molar here is your MC because the concentrated one. So your MC is 1 molar, right? So it will be 1 times 0.5. Then your MED is what the question is asking, right? So we don't know MED yet. And VD, that's the final volume you have is 1 liter. times 1 liter. Here, this MD, VD, the VD is the final volume, right? It's the volume from the diluted solution. Then we're going to calculate in here what's the value for MD. So you know that that will be what? To do the math, here will be 5 molar, right? 0.5 molar, actually, 0.5 hundred molar. So you know that's not A. The answer is not A. Okay, same we're going to do for B, C, D, and E. So for A was using the dilution formula, right? Let's try to solve for B. B here says you can make the solution here by preparing, by dissolving 46.7 grams of potassium sulfate in water and dilute it to a total volume of 250 milliliters. So this question B, sorry, this option B is not about dilutions, it's about dissolving. It means about making the solution from the mass, right? So in that case here, we are going to use molarity formula. That is, molarity is moles of solute, right? Divided by volume, the solution. So this letter here, for A, talking about the dilution, so we are going to use the dilution formula. But B is talk about dissolving, like making a solution from the mass, right? So, and then after so after taking the mass, weighting this mass, then we're going to add water to a final volume. So B and C are both using this formula here. And A, D, and E would be using this formula here for dilution. The one that gives the mass, then we are going to use the molarity formula, right? Okay. So let's solve B here. Moles of the solute. So what's the formula to calculate moles? Moles is what? Mass, right? Divided by molar mass. Molar mass. Okay, so the mass given here was 46.7. So 46.7 grams. The molar mass of potassium sulfate is 174. I don't have much room here. I'm gonna answer here. You can see better. So 100.7426. Let's write it here. So the moles is a mass, right? 46.7 grams divided by 174.26 grams per mole. This number here is the molar mass of potassium sulfate, right? That you find from in the periodic table, the molar mass of potassium times 2, then sulfur, then oxygen times 6, and then add up everything. You should find this molar mass here, right? Now let's divide 46.7 divided by 174 here. Here, 46.7 divided by 174.26. So the moles here are 0.26779 mole. Oops, I just 1 mole, 17 moles here. And then to calculate the molar mass, to calculate the molarity, after you find the moles, you are going to divide it to the volume. So molarity is 0.2679 moles divided by what's the final volume here? Little b says 250 milliliters. 2 liters, right, divided by 1,000 will be 0.250 liters. So let's divide here. Divide by 0.250. So the molarity for letter B is 1.07 molarity, right? So you know here, B is not the answer. So the question is asking what are the steps to prepare the solution? So it's not A and it's not B. Now we are going to do the same for C, D, and E. For C, we are going to try to find the molarity. Take the mass given, divided by the molar mass. So for C, it will be exactly the same thing, just change the volume, right? And then dilute it again for this one. So let's solve it for E. E says, right, the E option here says diluting 46.7 milliliters of 1.92 molar potassium sulfate solution to 250 milliliters. So here it's not talking about mass, right? Just talk about volume and the molarity here. Let's use dilution formula. McVC equal MdVd, right? So what's the concentrated one, right? So it says the one we are going to take this volume from this solution here, from the concentrated solution. So here, 1.5 is your MC, 46.7 is your VC, and the final volume, that will be the diluted solution, will be 250 milliliters. So molarity for the concentrated one is 1.90, right? Times VC, that is 46.7 milliliters, right? Okay. Equal to MdVd. MdVd is the volume of the diluted solution, right? We're going to be the final volume is 250 milliliters. So to find the final molarity, you multiply 1.9 molar, right, times 46.7 divided by 250 milliliters. So try to do that math here to figure out if the answer is E. So you should find, if the answer is letter E, you should find this amount here, this concentration. If the answer is not E, then you need to try C and D, right? Okay, so here, everything for this formula here is, I did not convert to liters because everything here is in milliliters already. So for the dilution formula, if everything is in the same unit, just keep, if the volume is already, everything, all volume is already milliliter, then don't need to convert to liters. But for letter A, one was in milliliter and another was in liter. That's why for letter A, I used the dilution formula, but I did convert to liters because the volumes here, they were in different units. And you cannot do that. You need to make sure all volumes are in the same unit. That's why for letter E, I did not need to convert because the letter E already gave everything in milliliter, right? Okay. So let you guys to calculate this one here. Okay. So now, number 4. What volume of a concentrated solution of magnesium chloride, so you know that this one will be your MC, right? Must be diluted to 250 milliliters to make a 2.75 molar solution of magnesium chloride. So no, here will be your molarity of the diluted solution, right? And here will be your VD. Now, what you needed was the volume of the concentrated solution. That means this portion here is asked for your VC, right? MC, VC equal MD, VD, MD, MC, you know that's the molarity of the concentrated. So is for the concentrate, that means it will be the molarity for the stock solution, right? The initial concentration here, 9 molar. So what is volume of the concentrated? So we don't know, let's call VC, right? Then MD, 2.75, right? Times the volume, 350 milliliters, right? So your volume of the concentrated solution will be 2.75 molar times 350 milliliters, right? Divided by 9 molar. And here we are going to find the volume already in milliliters, right? We're going to cancel molarity with molarity. And then please make sure you do this math here. Multiply, divide by 9, and we're going to find what's the correct answer here, right? Okay. So now about thermochemistry. So the questions from 1 to 4, they were all about chapter 4, right? Now let's talk a little bit about chapter 5, the thermochemistry. So this reaction here, it says the enthalpy for the formation of the aluminum, oxygen, right? Make aluminum oxide here. It says the enthalpy is a negative value. So if it's negative value, it means it's releasing energy. So if it's releasing energy, the reaction is exothermic. So if it's exothermic, therefore heat is released by the reaction. So the answer is C. But let's say that you have another reaction, A plus B, AB, just an example, right? In the delta H, if it was a positive number, right? Like positive number or no negative number, right? So this reaction here is, if the enthalpy change is positive, that means the reaction would be endothermic, right? If it is endothermic, that means the heat is absorbed by the reaction. right? So again, we are going to look for the question like this. We are going to pay attention to the sign. If enthalpy change is a negative number, the answer is the reaction is exothermic, so the heat is released by the reaction. But if the enthalpy change is a positive number, it means the reaction is endothermic, so the heat is absorbed by the reaction. Okay? Okay. So question 6 is also about thermochemistry. That's chapter 5. So the energy change of a system that absorbs 12.4 joules of heat and does 4.2 joules of work on the surroundings is. So let's see here. The energy change will be heat plus work. But sometimes the heat can be positive or negative, and the work can be positive or negative. So depends what the question is, what the question is saying here. We're going to look for the keywords. So here, delta E, the change here of a system that absorbs. So everything that says absorbing means gaining. If it's gain, that means 12.4 is a positive number, right? Okay. And then the system thus is doing the work. If it's doing the work, is spending energy, right? If it's doing the work so the system does 4.2 joules of work on the surroundings. So the 4.2 will be a negative number, will be minus 4.2 joules. But the question was saying that the system was receiving work, that it means he would be positive. But now the question says the system does the work, right? So I'm gonna let you guys to do the math here, just as a subtraction, and then answer for that will be A, B, C, D, or E here, right? Okay. So question 7 is about calorimetry. So the question about calorimetry, like, uh, will give specific heat, or will we ask for example, right? In that case here, the specific heat capacity of lead is 0.13 joules per gram Kelvin. So how much heat in joules is required to raise the temperature of 15 grams of lead from 22 degrees Celsius to 37 degrees Celsius? So for questions like this, you have delta T, right? You have the mass here, and here you have specific heat. So what's the formula here? Q is MC delta T. That's MCAT formula, right? So let's calculate here. The mass was given 15 grams, right? Times specific heat was also given, was 0.13 joules per gram Kelvin, right? And delta T is a subtraction, 37 minus 22. 37 minus 22, right? Will be delta T equal to 15 degrees Celsius. Just one note here. So specific heat is in Kelvin. So that means your delta T should be Kelvin. The delta T is same thing in Kelvin. So why the delta change, the temperature is the same in Celsius and Kelvin? So If I'm going to do 37 degrees minus 22 is 15 degrees Celsius, right? And if you convert the 37 to Kelvin minus 22 to Kelvin, the delta T also will give you the same answer, right? So whatever number, the delta T will be the same number in delta T in Kelvin. Just change the unit, just change the units. So, right. So then we're going to the calculation. 15 grams plus 0.13, right, for specific heat times 15 Kelvin. So then you can answer which one is the correct answer here, right? Okay. Okay, so next is number 8. Number 8 is about electronic configuration. Electron configuration is about chapter 6. So, what's the correct electron configuration for bromide ion? So it says ion, right? If it's ion, we have a charge here. But what will be the charge? Will be the charge be positive or negative? So bromine is right here, right? Group 7A, 17, 7A. So all these halogens here, all these elements, they will be, the ion will be a -1. That means the bromide, I was seeing here, I was seeing bromine here, right? So that means bromide will have 36. So the bromine has 35 electrons, but the bromide, the ion, because it gained 1 electron, will be 36 electrons. So bromine was 35, right, initially, plus 1 electron. Now you have 36 electrons. Okay, now let's see what's the correct answer. So you are going to find the order here by following this diagram here for electronic configuration. 1s2, until you count 36, right? 1s2, 2s2, 2p6, 3s2. So 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 2, 20, plus, then you are going to do the math here, right? So when I find which one will be the answer until you get 36 electrons. So make sure you answer the correct option here, right? Should be the total. Which one has 36 electrons here? When I counted the number, this number here. So 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, and then plus 10, plus 2, plus 6, right? Okay. Then the next one is about electron configuration. This one says ground state electron configuration. That means it is as it is here. So GA has 31 electrons. Electrons, right? 31 here. So are you going to check which one it has 31 electrons, right? We're gonna do the same thing. Follow like which one? 1s2, 2s2 until you arrive in 31. Okay, so as an electron moves closer to a nucleus, energy is So we have here the nucleus, right? Nucleus, and then the energy level here, energy level. So when the electrons jump from lower to a higher energy level, energy is absorbed, right? So here you have absorption. From like when the electron is moving further from the nucleus, you have absorption. But when the electron is jumping back to the nucleus, closer to the nucleus, you have energy is releasing, is released the energy. Because when you see the photon, you see the lights, is when the electrons are returning closer to the nucleus. So this is why the answer should be B. When the electron is moving closer to the nucleus, energy is released. Okay? Question 11 is about quantum numbers. What's going to be the answer here? So in quantum mechanics, right, an L value of 2 corresponds to a later designation of, okay, L is the secondary quantum number, right? It's the angular momentum. It's about which subshell we're talking about. So for subshell S, L will be 0. For subshell S, so P, for subshell P, L will be 1. For subshell D, L will be 2. And for F, L will be 3. So the question is, in quantum mechanics, an L value of 2 corresponds to a letter of which one? So for 2, you have the D. So the answer should be, let us see here, right? So just make sure you remember that S, for S, L is 0, P is 1, and F is 3, right? I do have here the orbitals, and each one, like S, you just have one orbital. P, you need 3 orbitals, right? To make sure you can fit the maximum of electrons. And D orbital, the subshell D can hold up to 10 electrons, so you need 5 orbitals, right? Each orbital, 1, 2, 3, 4, 1, 2, 3, 4, 5, yeah, right? Each orbital fits up to 2 electrons, right? And F can fit up to 14 electrons. That means for F, you needed 7 orbitals. So I'm gonna count here. 3, 4, 1, 2, 3, 4, 5, 6, 7. So to answer this question, we do not need this portion here, right? I'm just reminding you this portion here is about MEL. I'm just reminding you how many orbitals we have for E in each subshell, right? Okay. So all of the orbitals in a given electron shell have the same value as so shell will be the energy level, this the principal. But the principal quantum number is the first one, is N, that's the energy level. For example, for 2s2 here, right? The N will be, this number 2 will be your N. Okay, right. So the 13 is about the certainty of principle, states that it's impossible to know the exact position and momentum of an electron. So you don't know the exactly position and momentum. What you know is the probability to find that you have the quantum numbers, right? N, L, Ml, and Ms. They are like the GPS to find the electrons, right? But it's not 100%. The probability like is about 90% to find the electron using quantum numbers. So it's why it's important to know the exact position. So the answer should be the uncertainty principle should be C. All right. Okay. Then 14. Which one of the following is an incorrect subshell notation? Okay, so let's go to the diagram here, right? So you can see the S, all the electrons, all the energy level in the S subshell go from 1 to 7, or here, from 1 to 7. For the subshell P, starts on the second one. Go from 2 to 7. Right, so P starts on the second one. The D is the third subshell, the third that starts on number 3. Have you seen here? We do not have 1 and 2 for the D. So let's see what we have here. Which one of the following is an incorrect subshell notation? So for F, it's okay, right? Because the F starts on the 4. So for F14 is correct. So, but you don't have to do 2D, right? The D, the first one, D is in the 3D. The answer is B. So there is no 2D in electronic configuration. So the first subshell starts on 1. The second starts number 2. The third starts number 3. And the fourth starts on number 4. So the answer should be D. Okay. So then, question 15. Which electron configuration represents a violation of the Pauli exclusion principle? So you should, let's see here what says, what should be this one here? So no two electrons can have the same energy. So they cannot have the same exact four quantum number. This is Pauli principle says, right? So if you look at these electrons here on the C, to have these two electrons in the same orbital and both pointing up. That's not correct, right? In each box, it will be one up and another down. You don't have two electrons both pointing up. If you do this, we have the same four quantum numbers. That is not true, right? Here. No two electrons can have the same energy. That means cannot have the same exact four quantum number. So the answer is C. It's a violation because we cannot have two electrons in the same orbitals, exactly the same directions here. Okay, so question 16 is still about quantum numbers. Suppose the first two quantum numbers assigned to atom are 4 and L3. So what are the possible MEL quantum numbers, right? So N equal to 4, and L is a 3. When L is a 3, the MEL will range from -3 to +3. Write this number here. The wind also indicate what will be the range of your MEL. So the answer is D. The range will be from -3 to 3. By the way, what is the subshell here? What's on the previous question, right? If L is 0 for S, is 1 for P, 2 for D, and 3, so here should be 4 F, right? Do not say the electrons yet, so it's gonna be 4 F here. Because when L is 3, 4, subshell F. In the range for MEL, we will go from -3 to +3. So if the L would be 2, right? The MEL would be from -2 to +2. And then the same thing for 1 and for 0. Okay. Then number 17, a photon with a frequency of 2.1 times 10 to the fourth per second has energy of. So here, the question asks for energy and it gives frequency. There is just one formula that you can solve this question, that is using E times Planck's constant, right, times frequency. So we're going to solve this using Planck's constant. So energy was Planck's constant. So the Planck's constant will be given the exam, right? Oops. So Planck's constant is 6.626 times 10 to the minus 34 joule seconds times frequency. The question here already gave you the frequency. So times 2.1 times 10 to the fourth second to the minus 1. So we're going to do multiplication here. And then what would be the answer, right? So you can see here that the 2 seconds cancel out with second to the minus 1. So the answer will be something in joules, right? Okay. So question 18 is the energy of a photon that it has a wavelength of 90 meters. This question here did not give you the frequency. And to find the energy, you need the frequency. So, okay, so energy is Planck's constant, right, times frequency. So what do you do when we do not have a frequency? And then you're gonna calculate the frequency, right? What's the formula for frequency? Is speed of light divided by wavelength, right? Speed of light will be also given the exam that, by the way, is the C, right? So 3.00 times 10 to the 8 meters per second divided by wavelength. Wavelength should be in meters. In that case, it's already in meters, right? So we're going to divide 3 times 0 times 10 to the 8 divided by 9 to find your frequency. The unit for frequency should be second to the minus 1. Okay. So after the division here, you are going to get this frequency here and plug right here. So energy is Planck's constant, right? This number here, 6.626 to 6 times 10 to the minus 34th times whatever is this number here. Oops, let me write the unit, right? Joule seconds times this number here. I'm gonna let you guys do this math, right? So after you find this frequency, you are going to multiply Planck's constant times the frequency. And this should be your answer, right? That, by the way, will be in joules. All right. Okay. So, all right, I'm gonna stop here today, and then I will do the next portion in another video, okay? So you answer together here until question 19 from the worksheet.